In this video, we are going to explore the different types of rectangles that can be used to construct the fourfold patterns. Here we have three examples of different fourfold patterns constructed in different rectangles. In order to draw a fourfold pattern in a rectangle, the rectangle must have a specific proportion. You certainly cannot draw a complete and correct fourfold pattern in a rectangle that does not have the correct proportion. So what are these proportions and how do we construct these rectangles? There are only two cases where we can draw a complete and correct fourfold pattern in a rectangle. The first case is inside a rectangle that has a specific proportions, as in these two examples. The second case is inside a rectangle made from a combination of either a square plus a rectangle from the first case or a combination of rectangles from the first case also, as in this example. From these two cases, we can get a wide range of different rectangles that satisfy the fourfold proportions. But in all cases, the diagonal of a square plays a vital role in establishing these rectangles. Now let's deal with the first case. The rectangles that have a specific proportions are in fact only two rectangles. One is a primary rectangle, as in this example on the left, and the other one is a secondary rectangle, as in the example on the right. Again, in both these rectangles, the diagonal of a square plays a vital role, as we will see in few moments. To construct the primary rectangle, we have to start with a square first. Then we draw an arc centered at one of the corners of the square and with a radius equal to the diagonal. The result is a rectangle with a height equal to the diagonal of the square. As you can see, the pattern fits perfectly inside this rectangle. Mathematically speaking, this rectangle is called root 2 rectangle. This is the first rectangle of what is known as the dynamic symmetry root rectangles. The dynamic symmetry is achieved by using the diagonal of a square to construct the first rectangle. Then the diagonal of this rectangle is used to construct a new one. This process will create a progression of rectangles related to each other. It is worth mentioning here that the design and plan of Alhambra Palace in Granada was based entirely on the dynamic symmetry system. The key to Alhambra design is the relationship between the side of a square and the diagonal. Every part of the palace was designed using this system, including the geometric patterns that decorate the palace. In fact, all the geometric patterns used in Alhambra were based on the square and the root 2 rectangle. This is the secret of its harmony and beauty. Now let's go back to our subject. To construct the secondary rectangle, we have to start with a square as well. Then we extend one of the lines that divide the right angle to intersect with the opposite side of the square. In practice, this method was never used by craftsmen because they considered extending the lines is not accurate enough. To construct the secondary rectangle, craftsmen added a square to the root 2 rectangle. By adding a square, it looks like that the secondary rectangle is in fact a combination of the previous primary rectangle plus a square. Nevertheless, this rectangle is in fact a special case. It has very close relationship with both root 2 rectangle and the square itself. To demonstrate this relationship, we need to go back to the primary rectangle, i.e. the root 2 rectangle. If we take off the square from the root 2 rectangle, the result is a smaller version of the secondary rectangle. Therefore, the primary rectangle itself is in fact a combination of the secondary rectangle and a square. As a result, these two special rectangles complement each other, and we can generate one from the other and vice versa. Whether we add or subtract the square from the primary rectangle, the result is a secondary rectangle. The reverse is equally true as well. Whether we add or subtract a square from the secondary rectangle, the result is a primary rectangle. With the square, these two rectangles makes the perfect formula for symmetrical repetition, which is essential for geometric pattern art. And before I go any further, I want to go back to this middle pattern. As I said before, that this pattern is a combination of a square plus a rectangle of a specific proportion. In fact, this rectangle is a combination of one square and one root 2 rectangle. We can also say that it is made of two squares and one secondary rectangle. The dynamic symmetry and the relationship between these two rectangles is not limited to the boundary of the pattern. In fact, it goes deeper inside the structure of the pattern. If we examine the construction base of this pattern from Alhambra, we can clearly see that the construction lines generate these rectangles. Here is the root 2 or the primary rectangles, and these are the secondary rectangles. And we can look at it in another way. We can say that this is a big root 2 rectangle and the rest is a secondary rectangle plus a square. When we examine the construction lines of another pattern, both rectangles are clearly visible in the structure of the pattern. This dynamic symmetry goes even further to include the shapes in the pattern itself. For example, the height of the star is equal to two primary rectangles, and the diamond shape fits inside a secondary rectangle. This shape occupies an area equal to two secondary rectangles plus two squares and one primary rectangle. In fact, every single shape in the pattern fits into either a square or one of these rectangles or a combination of these three. These rectangles also appear diagonally. All these are root 2 rectangles. In fact, all the area is divided by root 2 rectangles and squares. From the previous video and this one, we can conclude that the relationship between the side of a square and its diagonal is vital in preserving the symmetry and the correct proportion of the fourfold patterns. Finally, I reiterate that none of this can be achieved through the grid method that is being presented by almost all authors. And I would like to advise all the people who are still using the grid method and drawing circles in an open space to abandon this type of method, because you're simply wasting your time by using this wrong method. Throughout my videos, I proved again and again that drawing the patterns using the grid method results in mistakes in many cases, not to mention the deformation and the lack of any proportion in the patterns. In the next video, I will show how to draw this fourfold pattern, which is constructed in a secondary rectangle. And thank you for watching.